Flymorton mechatronic body armor system. This technical narration describes the proposed layered armor, actuation, energy, communication, acoustic, magnetic, and trajectory control system. The Morton field effect portions are presented as German Morton's speculative engineering framework, not as established experimental physics. Section 1. Armor structure. The external shell is a segmented copper, aluminum, and high-strength composite armor structure. Beneath the shell are multiple functional layers. Layer 1. A diamagnetic layer, intended to oppose changes in an applied magnetic field. Layer 2. A ferromagnetic layer, using materials that can strongly magnetize and concentrate magnetic flux. Layer 3. A paramagnetic layer, intended to respond weakly in the direction of an applied magnetic field. Layer 4. An electric separator, electrically isolating conducted layers and helping prevent short circuits. Layer 5. A conducted copper and aluminum layer, distributing current, shielding electronics, and providing a path for induced eddy currents. Layer 6. A crystal radio coil and transceiver layer for passive signal detection, telemetry, identification, and short-range communications. Layer 7. A battery armor layer containing protected energy storage modules distributed through the torso, hips, arms, and legs. Layer 8. A voltage capacitor layer used for pulse buffering, transient current delivery, and recovery of short-duration electrical energy. Layer 9. A PNPN transistor armor layer, treated as a conceptual switching and rectification layer. In practical electronics, this function would require engineered semiconductor devices, insulation, heat control, and verified switching circuits. Layer 10. A transducer bonded armor layer that converts electrical input into mechanical vibration, acoustic output, sensor response, or electromagnetic actuation. Layer 11. An electroacoustic driven armor layer using piezoelectric, magnetostrictive, or electrodynamic transducers. Layer 12. A permanent magnet interaction layer intended to produce attraction or repulsion against a suitable external magnetic field or reduction surface. Layer 13. An ion and eddy current transmitter layer intended to generate controlled electric fields, induced currents, sensing signals, and electromagnetic braking or coupling effects. Section 2. Coil and actuator systems. The armor includes copper primary coils, iron core secondary coils, aluminum shielding or low-mass conductor coils, linear solenoids, collapsible coil inductors, and common element stacked inductors. The copper coil provides low-resistance windings for current-driven magnetic fields. The iron core coil increases magnetic flux density but also adds mass, hysteresis loss, and heat. The aluminum coil lowers mass but normally has higher electrical resistance than copper through the same dimensions. The linear solenoid converts electrical current into straight-line mechanical motion. The collapsible coil is a flexible or telescoping inductor designed to change shape with joint movement while maintaining electrical continuity. The common element stack combines conductor, electric, magnetic core, insulation, cooling, and structural support into one modular actuator. The armor actuator mounted over aluminum foil uses the foil as a conductive shield, electrode, or eddy current reaction layer. Aluminum foil alone cannot provide reactionless thrust. A measurable force requires interaction with another fuel, conductor, fluid, expelled mass, or external reaction surface. Section 3. Power conversion. A voltage transformer changes alternating voltage according to the turns ratio. The ideal transformer relationship is V2 divided by V1 equals N2 divided by N1. The electrical power is approximately P equals V times I. Ohm's law is V equals I times R. Energy stored in a capacitor is E sub C equals 1/2 CV squared. Energy stored in an inductor is E sub L equals 1/2 Li squared. The armor battery supplies direct current energy. Power electronics convert and regulate this energy for coils, sensors, acoustic emitters, communication devices, servos, and cooling systems. Section 4. Electromagnetic laws. The force on a moving charge is described by the Lorentz force equation, F equals Q times the quantity E plus B cross B. Through a current carried in conductor, the force is F equal L cross B. Faraday's law states that induced voltage equals the negative rate of change of magnetic flux. EMF equals negative d phi b over dt. Inductance may be represented as L equals N phi b divided by I. Magnetic energy density and coil heating must be controlled because high current produces dual heating. Heat equals I squared R. Newton's second law controls the final motion. The net force equals mass times acceleration. Newton's third law requires an equal and opposite interaction. A wearable linear induction system therefore needs a reaction rail, conductive plate, magnetic track, expelled mass, aerodynamic flow, or another external momentum exchange mechanism to create sustained net thrust. Section 5. Acoustic and vibration systems. The electroacoustic armor contains harmonic sonic oscillators, electromagnetic vibrators, body transducers, and horn-type acoustic emitters. Acoustic pressure is force divided by area. P equals F divided by A. For a traveling sound wave, acoustic intensity can be approximated by I equals TRMS squared divided by rho C. Acoustic radiation pressure is approximately P radiation equals I divided by C for absorption, or approximately 2I divided by C for ideal reflection. Acoustic radiation force is F radiation equals P radiation times area. These equations describe forces transferred through a material medium, such as air, water, or a solid. Ordinary acoustic waves do not propagate through a perfect vacuum, and acoustic radiation has not been demonstrated to displace gravitons or cancel inertia. The harmonic oscillator relation is F equals negative Kx. The resonant frequency is F equals 1 divided by 2 pi times the square root of K divided by M. The armor controller must avoid resonances that could injure the wearer, loosen fasteners, damage organs, or overheat the transducers. Section 6. Magnetic energy harvesting. The active magnetic energy harvesting transducer converts changing magnetic flux, vibration, joint motion, or environmental movement into electrical energy. The induced voltage follows Faraday's law. EMF equals negative N times d phi b over dt. Energy harvesting can recharge sensors or recover small amounts of energy. It cannot create perpetual energy and cannot return more usable energy than the mechanical or electromagnetic energy entering the system. Section 7. Communication and control. The helmet includes a transceiver module, crystal radio coil, inertial measurement unit, position sensors, pressure sensors, temperature sensors, current sensors, and an integrated display. The controller measures acceleration, angular velocity, magnetic field, suit temperature, battery condition, actuator position, and acoustic output. The control force equation is F control equals M times the quantity desired minus a measured. The total controlled force may be written as F control equals F solid plus F electromagnetic plus F mechatronic plus F aerodynamic plus F repulsive. This is a guidance and control equation. It does not by itself create energy or alter space-time. Section 8. Free-fall geodesic guidance. In general relativity, a free-fall geodesic is the natural path followed when no support, thrust, drag, or contact force acts on an object. The geodesic equation is d squared x move over d tau squared, plus gamma mu alpha beta times dx alpha over d tau times dx neta over d tau equals 0. A powered suit is not following an end-left geodesic while its actuators are producing proper acceleration. The suit may calculate, enter, and actively track a ballistic or orbital route, then reduce thrust after reaching the required position and velocity. The practical trajectory controller is F control equal m times the quantity a desired geodesic minus a measured. A low Earth orbit requires very high sideways velocity. Reducing air drag alone does not place a person into orbit. The system must supply the required momentum and must safely manage acceleration, heat, power, navigation, and life support. Section 9. Morton Field Effect. Speculative Model. German Morton's proposed sequences. Harmonic armor oscillation, longitudinal acoustic pressure generation, electromagnetic fields inclination, proposed displacement or reduction of hypothetical graviton-like or riveted interactions, reduced motion resistance, and lower corrective force requirements. A conceptual interaction factor is Fr, m equal Fr, 0 times the quantity 1 minus chi m. A conceptual motion equation is m equal F repulsion plus F electromagnetic minus F drag minus Fr 0 times the quantity 1 minus chi m. A proposed unified control expression is F equal F electromagnetic plus F acoustic plus F inertial. The proposed Morton field potential may be represented symbolically as an integral of electromagnetic, mechanical, and acoustic contributions over time. These Morton field effect equations are conceptual placeholders. Gravitons remain hypothetical and have not been directly detected. Rivitons are not established particles. No verified experiment currently shows that acoustic radiation, permanent magnets, induction coils, or electric coatings can cancel gravity, reduce inertia, manufacture a space-time geodesic, or produce reactionless flight. Section 10. Engineering Interpretation. The scientifically defensible version of the Flymorton armor is a powered exoskeleton with distributed batteries, capacitors, inductors, electromagnetic actuators, acoustic transducers, sensors, communication equipment, thermal management, and guidance software. Sensors, communication equipment, thermal management, and guidance software. The suit could assist movement, produce vibration, transmit sound, couple to specially designed magnetic or conductive surfaces, recover limited energy, and calculate free-fall or orbital trajectories. For actual flight, it still requires a verified source of lift or thrust, adequate reaction mass or external momentum exchange, safe power density, structural strength, cooling, stability control, and human-rated protection. End of Flymorton Mechatronic Body Armor Technical Narration.